In previous class, I discussed about path, BGP path attributes, right? Yeah, that's fine. That's fine. We discussed enough path attributes, right? And now during practicals, I'll be covering all the attributes, right? And once again, I'll elaborate each and everything. So that's fine from that point. Now, I was discussing about IBGP and EBGP, right? So I just taught you that if your neighbor is in same AS, then you will call that as IBGP neighbor, and if your neighbor is in different AS, then you will always call that neighbor as a EBGP neighbor. If you are receiving anything from your IBGP neighbor, that will be called, or that will be known as internal prefix. And if you are if you are receiving anything from your EBGP neighbor, that will be called as external prefix, right? So now let's talk about loop prevention mechanism in BGP, right? Loop mechanism in BGP, right? So you know, in BGP, if any router, or if be in BGP, if it receive any update, right? There is a very simple rule that if BGP receives any update, and if it receives it's on AS and received, if it, you can say not it, if it receive, it found, right? If it found it's on AS in received updates, it will simply discard them. It will simply discard them, which means this is router 1, this is router 2, router 3. Router 1 is running AS 100, it's running AS 200, and R3 is running AS 300. If R1 is having a prefix 10.1.0/24, right, then it will forward this information to R2, that if you want to reach 10.1.1.0/24, then you have to cross AS 100. Then this information will be forwarded, from R2, this information will be forwarded towards R3, that if you want to reach 10.1.1.0/24, then you have to cross 200 and 100, right? Whenever this router 3, okay, let's assume that R3 was running AS 100 itself, right? So whenever this R3 will receive this update, it will find that, okay, to reach this prefix it has to cross AS 200 as well as AS 100, and this AS 100 is configured on R3 itself, right? So it will simply discard all these incoming updates. R3 will never accept all these updates, it will simply discard them. That is why, in case if your routers are connected in this manner, let's say this is router 1, this is router 2, this is router 3, right, and all of them are connected in this manner, right, let's say there was a prefix on R1 that was, let's say 10.1.0/24. On R1 let's say we are running AS100. On R2 we are running AS200, right? And on R3 we are running AS300, right? AS100, 200 and 300. If this R1 is giving any update to R2, then R2 will forward it towards R3, and then R3 can forward it back towards R1. But whenever R1 will receive it from R3, it will simply discard them. So there will not be any possibility of loop formation in this kind of scenario, right? But you must remember, or even in previous class I taught you that whenever BGP updates will be going towards eBGP neighbor, then only it will prepend its own AS, right? Whenever it will be giving an update to its iBGP neighbor, then it will not prepend its own AS onto all outgoing updates, right? And of course it must not prepend if it is giving an update to its iBGP neighbor, because if let's say that this is router 1, this is router 2, both of them are in same AS100, it is also running AS100. If R1 is giving any update to R2 after prepending its own AS, definitely R2 is not going to accept all those updates, right? That is why there is a rule that whenever you will be giving an update to your iBGP neighbor, you will never prepend your own AS onto outgoing updates, right? But whenever you will be giving an update to your eBGP neighbor, then it will always perform prependation in outgoing updates. I hope that you people have understood it now, right? So this is the technical reason, so that whenever it performs prependation for eBGP neighbor, but it does not perform prependation for iBGP neighbor, right? I hope that you people have understood this point now. Fine. Apart from that, fine. After it, so this is the rule for this. This rule is also called split horizon rule in BGP, right? Apart from that, one another rule is also there. See, if this is router 1, this is router 2, and this is what, router 3, and all of them are in same AS100, right? All of them are in same AS100. So R1 will be giving its own update. Let's say it is 10.1.0/24. So it will give this update to R2. R2 can give it to R3. R3 can give it back to router 1. So R1 will be giving this update to R2. R2 will be giving this update to R3, and R3 will be giving this update back to R1. So now you must remember that, okay, in this condition there can be a routing loop. To avoid it, again we are having a rule in BGP. And one more thing, because in this case they are not going to perform prependation, that is why whenever R1 will give any update to R2, R2 will accept it. When R2 will forward that update to R3, R3 will accept it. Whenever R3 will give that update to R1, R1 can accept it, right? Because they are not prepending ASs in their outgoing updates, right? Because all of them are iBGP neighbors. Fine. One more thing that you must remember, that due to this thing, or due to this nature of BGP, there can be a routing loop. So to prevent its network from routing loops, now there is a rule in BGP that if any update is coming from one of the iBGP neighbor, it will never forward that update towards any other iBGP neighbor. So what does it mean? That if R1, R2 and R3, they are connected in a sequence, right? And let's say that all of them are in same AS, right? So if all of them are in same AS, then if R1 is giving anything to R2, now R2 will never forward that information towards its another iBGP neighbor, or toward other BGP neighbors, right? So you will see that if R2 is receiving anything from R1, then R2 will never forward that information to R3. If R3 is giving anything to R2, then R2 will never forward that information towards R1, which means that if all these three routers are in same AS, then R1's prefix will not be available on R3, and R3's lane will not be available in the routing table as well as BGP table of R1, right? So this rule is by default enabled in BGP just to prevent your network from routing loops, right? Now the point is, for an example, if we are having this kind of scenario, let's say this is router 1, this is router 2, and this is router 3. Now we need to, you know, exchange routes between R1, R2 and R3, right? And all of them are in same AS 100, and all of them are having iBGP peering. right? 100, and all of them are having IBGP peering, right? So in this case, what can we do? We can form fully meshed IBGP peering. Like we can form IBGP peering between R1 and R2, and then another IBGP peering we can form between R1 and R3. And that is why we are always required to configure IGPs in the background of BGP. So with the help of EIGRP and OSP, we can form routing in between R1 and R2 and R3. We can create a loop back onto R1, onto R2 as well as R3. Then we can form neighborship between them with using their loop back interfaces only, right? So R1 will form neighborship with R2, and R1 can also form neighborship with R3. So in case of IBGP, like if you are running IBGP in your environment, then make sure that you are having fully meshed neighborship. Of course, I will give you another another solution for that, so that you will not require to configure IBGP in fully meshed way, right? So I'll be giving some technical solutions for solving this problem, but before that, you must remember, or you must remember that there is a rule for IBGP, that in case of IBGP you must have fully meshed neighborship between all IBGP peer, I mean between all routers in a single AS, right? So in this way we will be configuring all these things, and that is why, you know, in BGP it is always preferred to form IBGP peering with using their loop back addresses, right? In most of the cases in production environment as well, you will always find IBGP peering in between two devices, but with using their loop back interfaces, because in the background of IBGP they will always configure IGP, such as either OSPF or ISIS. In most of the cases you will find ISIS at the end of service provider. You know why? Because ISIS will always be configured in the background of BGP. BGP will be running in front, right? But in the background of BGP you will always find any linked state routing protocol, whether it is ISIS or OSPF. But in most of the cases, at the end of ISPs you will find ISIS, because ISIS is that protocol which is completely linked state routing protocol, whereas OSPF is optional. If you are using single area OSPF, then it is completely linked state routing protocol, and if you are using multi-area OSPF, then you know it will be having some features from distance vector as well. So there can be a problem related to traffic engineering, because traffic engineering can be configured in OSPF if you are running single area OSPF. If you are running multi-area OSPF, then traffic engineering will not be possible over there, right? So that is why, and if even EIGRP does not support traffic engineering, that is why at the end of ISP, in the background of BGP, you will never find this EIGRP. You will find either OSPF or ISIS, because these two routing protocols supports traffic engineering for MPLS, right? So this is the reason that behind BGP you will always find either ISIS or OSPF in ISP's network. Fine. Apart from that, so I have told you that how BGP prevents itself from routing loops. First, for eBGP, like if any router is receiving any BGP update from its eBGP neighbor and it find its own AS in those received update, then it will simply discard all those incoming updates, right? But in case of IBGP, if it is receiving anything from its one of the IBGP neighbor, then it will never forward those updates, that information towards other IBGP peers, right? So I hope that you people have understood it now. Fine. After it, let me tell you next hop behavior. Next hop behavior in BGP. There are certain rules related to next hop in BGP. Whenever you will be giving an update to your eBGP neighbor, next hop will always get modified. If you are giving an update to your IBGP neighbor, next hop will never be modified. Will never modified. These are very simple rules. What does it mean? Just try to understand in this manner. Let's say this is router 1. Here you are running AS10, AS20, 30, EBGP, right? Now let's say there is a here you are running 12.1.1.2.1. My control Z is not working. .2, 23.1.2.3, 34.1.3.4, right? Behind, I mean, in lane of R1 you are having 10.1.0/24, so R1 will be giving this update to R2 that if you want to reach 10.1.0/24, you have to across AS10, and your next hop will be 12.1.1.1, right? Then R2 will be giving this update to R3. So whenever these updates will be given to R3, then here R3 will install them into its BGP table. That 10.1.0/24 can be reached after crossing AS20 and of course 10. And next hop will be 23.1.2. Then R3 will be giving this information to R4 that if you want to reach 10.1.1.0/24, then you have to across AS 30, 20 and 10, and next hop will be 34.1.1.3. So now in case of EBGP, its behavior is same as either EIGRP or OSPF, because in EIGRP and OSPF and RIP, if router was receiving an update from one of the neighbor, then before forwarding those updates, those prefixes towards any other neighbor, they were modifying their next hop address, right? So here in case of EBGP, there will not be any problem. There will not be any type of problem actually. Any problem? So behavior of EBGP is same as other routing protocols. Fine. But in case of IBGP, let's say all of them are in same AS, right? Whenever R1 will give an update to R2, it will be 10.1.0/24, let's say via, fine. Then R2 will be giving this update. However, by default, BGP is not gonna to forward any update which is received from one of the IBGP neighbor to any other IBGP neighbor. But let's say that we modified the configuration of BGP, and now BGP can send those updates. I mean, can send all those updates which were received from one of the IBGP neighbor toward other IBGP neighbors, right? So R3 will be installing this prefix in its routing table in this manner via 12.1.1 itself, right? Then R3 will be giving this update to R4 that if you want to reach 10.1.0/24, then via 12.1.1.1. So remember that if you are giving an update to your IBGP neighbor, next hop will never be modified. If you are giving an update to your EBGP neighbor, then your next hop address will always modified, right? Or even in case if this is R1, this is R2, this is R3, this is R4. Here let's say they are having EBGP peering, here they are having IBGP, here also they are having IBGP. Let's say here it is 12.1.1, here 2, here you are using 23.1.2, here you are using 3, 34.1.3.4. Let's say here there is a prefix in .1.0/24, so to R2 it will be giving this prefix in this manner, that via 12.1.1. Now this is what IBGP neighbor, so it is not gonna to modify its next hop address. It will still remain as 12.1.1, and here also even, I mean, whenever any update will be forwarded towards an IBGP neighbor, then its next hop address will never get modified, never ever. And you know why? What's the reason behind it? As I told you before, that in the background of IBGP you will always be running IGPs. So point is here that if there is 12 network, of course you have to advertise it, or like for an example, all of them are IBGP neighbor, and 12 network is is configured as a next hop address throughout the network on all devices, then you will be running IGP in the background of BGP, right? So of course next hop address will be reachable via IGPs, either OSPF or EIGRP, or whatever it is, ISIS or whatever, right? So next hop address will still be reachable, so there will not be any problem. But remember, in BGP, if your next hop address is not reachable, remember that in BGP, if your next hop address is not reachable, BGP will never install that prefix in its routing table, Yes, in its routing table, it will keep that prefix in its BGP table, but will never define that prefix as best prefix. It will never make that as best. And remember, BGP works as a distance vector routing protocol. Means BGP will always forward only best path information towards its another neighbor. BGP will be giving only best path information. And remember that in BGP table, if next hop address is not reachable, it will never be mentioned as a best path. And in its local routing table as well, it will install only and only best routes. Tell me. If there is any problem, do let me know. Sure. Fine. Let's start doing some configuration of BGP now. This is 12.1.1.2 in this manner, right? Fine. Right? topology is quite simple, but you will understand this the basics of BGP completely with using this topology. Only basics, nothing else. Fine. First of all, let me show you that how BGP works. So I'll teach you that how to form neighborship in between two BGP speaking peers, right? So I'm going to form IBGP peer in between R1 and R2 first of all. So to do that, router BGP, you can use any AS number. It does not support 32 bits long, 32 bits long AS right now. In future I'll be using that. I will be using the 7200 series of routers, and with using those routers I'll be configuring 4 bytes long AS. So I'll be saying neighbor 12.1.2. Remember, in BGP you have to always configure your neighbors explicitly. In BGP there is no concept to form neighborship dynamically. Yes, there is a concept in which you can form neighborship dynamically, but in DM VPN only, and over there I'll be teaching you that okay, with using this method in BGP neighborship can come up dynamically, right? But again, that's not completely dynamic actually, right? I'll be discussing it later on, but right now you just need to define your neighbor statically, right? So then you have to define your remote AS, right? Remote AS is what? Let's say it is same, right? 100. R2 is also in AS 100. Now you will see that it will try to send, like here you can see that it will start sending some messages, and on R1 if itself you can see show IPBGP summary, it is in active state actually, right? So just wait for a moment. You see it has generated what? SYN message, right? But it is generated SYN message in source port number. It is using 64506 and destination port number is 179. So it is sending this SYN message. Even inside the flag you can find this SYN packet, right? SYN is there. So that information is contained by, and you can also see that this is the MSS, right? And window size, everything is going inside the first TCP packet. As I told you that during TCP session establishment they will be negotiating their window size, their MSS and everything, right? Fine. It is sending SYN message, but R2 is sending reset message back to R1. You know why? Because right now R2 is not listening anything for port number 179. So remember that if any device receives any packet with destination port number, right, and if that device is not giving services for that destination port number, then it will simply discard all those. It will send simply reset message, right, back to the sender in response of SYN message. So you can move on R2 now, and you can also define BGP peer over here. That you can say neighbor 12.1.1 and remote AS is going to be now 100, right? So that now you will see that neighborship will come up in between R1 and R2, right? So you can move on R1 now, and you can see show IP BGP summary, and you can see it is still in active state, but finally debug IP BGP. Fine. Oh, neighborship has came up now. So you can see now that it has formed three-way handshaking now. SYN plus ACK, and finally final acknowledgement, right? So three-way handshaking came up, and then first of all R1 generated open message to R2, then R2 giving another open message to R1, back to R1. Even you can open this open message. You can find that inside TCP this BGP information is going, and this is the open packet, message type 1, optional parameter, multi-protocol extension is there, and here unicast address family is there, route refresh capability is there, optional parameter, route refresh capability is there, right? Route refresh capability. So these capabilities are going within the open packet, right? My AS is going, version is going, length is going, hold down timer is 180 seconds, and BGP identifier, which is the router ID of this, right? And some optional parameters are also going along with open packet, and these parameters will define actually will define that which capabilities are by default there in BGP, right? So you see that open packets have been generated by both of them, and then they have started sending keep alive messages to each other. And you can open this keep alive packet as well, and you can see that what kind of information is contained by keep alive. So it is just saying that okay, I'm still alive, right? And then after they are sending keep alive packets in every 60 seconds. You can see that keep alive messages are going there, right? Keep alive, right? So they are giving keep alive packets to each other. Now neighborship has came up. To see your neighborship, command will be show IP BGP summary, right? It will show you that is your neighborship formed, is your device having any BGP peer or not. So this time it is having neighbor 12.1.2, version is running 4, this is AS, this is remote AS, right? Message received from this neighbor 5, and we have sent 5 messages to this neighbor. Table version is 5. Table version is something like revision number in BTP. So whenever it will receive any update from this neighbor, its table version will be incremented by 1. Input queue, nothing is in its input queue, nothing is in its output queue. This neighborship came up before 2 minutes 2 seconds, and then after state, if it is showing you any state, which means it is stuck in that state. If it is nothing listed, if there is nothing under state, which means that it is in established state. And prefix received, which means it has received 0 prefixes, because we didn't advertise anything in BGP yet. That is why it is not receiving anything from its neighbor, and that is why it is specifying 0 under prefix received. I hope that you people have understood it now, right? Then after it, you can even see BGP table, show IP BGP. You will not be able to get anything inside the BGP table. It does not have anything over there, right? Then after show IP BGP neighbor command is also there. So you can also run this command, show IP BGP neighbor. You can see that right now it is having neighborship with this 12.1.2, remote AS is 100, internal link, which means that it is an IBGP neighbor, right? Then after you can see that version is running 4, remote identifier is this is the remote router ID, right? And then after BGP state is established, and it is up for 3 minutes and 20 seconds, right? By default, hold down timer is 180 seconds, keep alive interval is 60 seconds. Neighbor capabilities, as I told you before, even we saw inside the open message that it was containing address family IPv4 unicast advertised and received, and along with that it was also having route refresh capability. I'll let you know that what is the meaning by address family IPv4 unicast over here, and what is the meaning by route refresh capability, but later on. It has sent 1 open message, it has received 1 open message, it has sent 5 keep alive, it has received 5 keep alive, total 6 messages received, 6 messages sent. Default minimum time between advertisement runs is what? 0 second for IBGP neighbor, right? Which means that if it has given any update to its IBGP neighbor, then after how long time it will send next update to its IBGP neighbor. So what is that? 0 second, right? Then after you can see that by default address family IPv4 unicast is running, table version is 1, neighbor version is also 1, output queue is size 0, and prefix is current 0, because we do not have anything inside our BGP table. So we have not sent anything, we have not received anything, right? Prefix is total, nothing. Implicit withdrawn, nothing. Explicit withdrawn, nothing, right? And then after we can see total total prefixes, right? Outbound, inbound. So we do not have anything. Number of NLRI in the update sent, right? So we have not sent any single NLRI in update packets, right? NLRI can have multiple prefixes in it, right? Connection established, drop 1 0, last reset never, we never resetted this peering, right? And we can also see that minimum incoming TTL is what by default? 0, right? Which means that if any prefix is coming with TTL 1, then if BGP packet like open packet or keep alive packet is coming with TTL 1, then also it can accept that, right? Outgoing TTL by default for IPCP neighbor, whenever it will generate any packet, by default its TTL value will always be 255, and minimum incoming TTL will be 0. Local host is 12.1.1, local port number is this in TCP session, right? And foreign host is this, and foreign port number is what? 179 on R1. Connection table ID in VRF, so there is no VRF available, right? And then after it you can see that that's fine. That's what we were needed to know about BGP in its neighbor table. Fine. Let me show you that how does it form neighborship. Debug IP BGP. Say clear IP BGP start to reset your neighborship. That's fine. Went from established to ideal, then ideal to active, then active to open send, then open send to open confirm, and finally any problem? Are you okay with this statement? Let's talk about that how to configure eBGP neighborship now. On R1, I'll be saying router BGP 100 neighbor 12.1.2 remote AS is this time 200. Fine. Then I'll be moving on R2. Remote AS is 100. Neighborship must come up. Has came up now. So IP BGP summary. Right? So IP BGP neighbor. For eBGP neighbor, there are certain rules. This is external link, which means that it is an eBGP neighbor. State established, sent open, sent received open, sent keep alive, update. Is not it? Received keep alive, update. Total messages. Default time interval in advertisement is what? 30 seconds. So for eBGP neighbor, it's, you understand? The default time interval in between two advertisement will be 30 seconds. But for iBGP neighbor, it was 0. Right? Then by default, its incoming TTL is what? Minimum incoming TTL is what? 0. It's same as iBGP, but outgoing TTL is now by default 1. Then again source port number, source host, local port number, remote host, foreign host and foreign port number, which means remote host and remote port number. Right? Even you can look at this show TCP brief. You can also look at here. Show TCP statistics. Show TCP. Right? Fine. After that, let me tell you that how can you configure neighborship with using their loopback interfaces now, right? So I'll be doing one thing, say no router BGP 100 from R1. Similarly, I'll remove it from R2. Now I'll create one loopback interface on R1. Similarly, I'll be creating one loopback interface on R2 as well. Right? And this time I want to form neighborship between them with using their loopback interfaces. That's fine, one is there, right? So in BGP, as I told you, that the only thing which is required is just reachability. You must have reachability with your neighbor. So you can try to ping with 2222 remote AS, 222, right? So it's not possible. Even you should have tried it with using your own loopback. That's not possible, right? So we must configure routing between them to configure iBGP peering, right? So I'll be saying that IP route, let's say I configure this default route 12.1.2, right? Similarly, I can configure one another default route onto R2. You understand? So now from R1, you must be able to communicate with the loopback of when source is your own loopback, right? So it is possible now. It is very much possible, right? So do one thing, router BGP 100, right? Neighbor 2.2 2. Remote AS is what? Let's say it is same. The neighbor 2.2.2 update source. In source it should take its loopback address because we wanna form now neighborship between their loopback interfaces only, right? So you have to change your update source. I mean you have to change your source of your outgoing packets, right? Because by default source address will be your exit interface's IP address. By default source address in outgoing updates in outgoing packets will be its exit interface's IP address, right? So I just configured its update source and which is loopback 1, right? And then after in similar manner I'll move on R2 and I'll be configuring same AS 100 neighbor 1.1.1. Remote AS is what? 100 neighbor 1.1.1 and update source is loopback 1. Any problem? So IP BGP summary. It is an active state. It is still in active state and it will always remain in active state. You see debug IP BGP, check it out. What is happening actually? What is it saying? No route to, but we are having that route to peer, right? But remember the BGP does not trust default route. BGP does not trust default route for its neighborship. So if you are having only default route on both ends, and forget about BGP peering now. It does not trust, by default BGP does not trust default route. That is why it is showing you that no route to peer. Do one thing, say no IP route 000, say IP route next hop is, it will work fine. At least one end must have a dedicated route. I mean at least one end must not have default route. Now you will see that, sorry, actually I should have configured IP route. Now it is having that route and now your neighborship must come up with. Done. So it can be your problem in your network, right? Might be that you are having reachability with the help of default route on both ends. So remember that if you are having reachability between two endpoints with the help of default route only, forget about BGP. Your BGP peering will never come up. At least on one end you must have a non-default route. So neighborship is up, right? So now we saw that IBC peering has came up without any problem, and the problem was just default route, right? So then after, let me do one thing. Let me say no router BGP 100, and this time I'm going to configure EBC peering between them, right? So no router BGP 100, and this time I'll be configuring EBC peering between them. Router BGP 100, neighbor is 2.2.2, remote AS is what? 200, neighbor 2.2.2, and update source is loopback 1. That's fine. Move on R2. router BGP 200, right? Neighbor is 1.1.1, remote AS is going 100. 1.1.1 update source is loopback. Neighborship must come up because this time they are not using default route, right? So IP BGP summary. BGP neighborship is stuck in, at least in previous case, neighborship was stuck in active state, but this time it has stuck in idle state. Why? Due to TTL. Wow. By default, for BGP neighbor, its outgoing TTL is what? 1. But we are required only 1. Don't you think so that we are required to have only one TTL value 1? Because my neighbor is just 1 hop away. My neighbor is just 1 hop away, so we should not have requirement. We should not have required, to have more than 1 TTL value. Of course, it must be sufficient.
Because our loopback is some kind of another network connected.
Oh my God! But still, it is available on same device. It's not gonna to see whenever router will switch a packet out from the interface, then only it will reduce, it will deduct its TTL value. But this time packet is belonging to its own directly connected interface. It's not gonna to switch this packet out from any interface, so it will never drop this packet. And you see, it will be depending on TTL value, but during active state only. It is stuck in ideal state, and in ideal state it is not gonna to generate any single packet now. Even it is not initializing its TCP session. As you know that in ideal state, even it will not initialize its TCP session as well.
BGP doesn't start.
So it is not happening due to TTL value. Very first thing. Because TTL value will come into the picture when it has initialized at least its neighborship. You understand my point?
Yes.
We can say that okay, it is happening due to TTL, but in that case only when at least it is trying to form neighborship, but this time it is in fact it is not trying to form neighborship.
According to FSM cycle, BGP is stopped.
Right? So now remember, there is a rule in BGP that is directly connected rule. Directly connected rule. There is a rule in BGP that is called directly connected. What does it mean? That for BGP, eBGP neighbor must be directly connected. eBGP neighbor must be directly connected. Then only it will initiate BGP peering. If neighbor is directly connected, then only it will initialize BGP neighborship, BGP peering. If your neighbor is not directly connected, then it is not going to initiate your BGP peering. So in BGP, there is a default rule that is called directly connected check. Directly connected check rule, which is by default enabled in BGP. So due to that rule only, it is not initializing this neighborship, not due to TTL. You understand? So due to direct connected check, directly connected check, right? Due to that rule, it is not initializing this BGP peering, because it knows very well that okay, neighbor must be directly connected, but it is not directly connected, and that is why there is no need to initialize. There is no need to initialize this peering. So by default, eBGP neighbor must be directly connected. To disable this feature, we can say router BGP 100. We can say neighbor 2.2.2 disable connected check. Similarly, I will move on R2. I'll say neighbor 1.1.1 disable connected check. So this time at least it will initiate TCP session, right? It will initiate BGP peering. You see now, show IP BGP summary. Check it out. Now it is in active state. If it does not form neighborship from here, which means that packets are getting dropped due to TTL value, but neighborship has came up. So remember, router will always decrement TTL value of the packet whenever it will be forwarding that packet out from any interface. Got this point? So due to directly connected check rule, if you are trying to form eBGP peering between two directly connected devices itself, but with using their loopback interfaces, it will never form neighborship. Even it will not initialize it. Now you have two options to do that. First, either disable your connected check rule or change outgoing TTL value. Change outgoing TTL value. One more thing, you can also disable this rule of directly connected check by changing its outgoing TTL value. Like if you configure your outgoing eBGP multi-hop, there is a command eBGP multi-hop which is used to change your outgoing TTL value for BGP, right? If you modify your outgoing TTL, then also this rule will be by default disabled. But why should we change outgoing TTL value if we know very well that my neighbor is just one hop away? If my neighbor is just one hop away, then why should we change outgoing TTL value? Are you getting my point or not? So if you are trying to form eBGP peering between two adjacent devices but with using their loopback interfaces, then you will never require to change its outgoing TTL value. You will simply disable this directly connected check rule and it will work fine. But remember, in case if your eBGP neighbor is more than one hop away, then this rule cannot be, like if you disable this rule, then also they will not be able to form neighborship because your packet will be dropped by transit devices. You understand? So in that case, it will be mandatory for you to change its outgoing TTL value if your neighbor is more than one hop away. Understood? Fine. So all these things are there in BGP and you must be familiar with all these concepts of BGP. Fine. Then after it this is that how can we configure, how can we form BGP peering in between two adjacent devices, right? In future I will also let you know that how can you form indirect neighborship in between two devices, right? But I'll be discussing it later on. For now, let's do one thing. Let's learn that how to advertise prefixes into BGP. So right now you can see do show IP interface brief. Does it have any lane network? No. So on F0 by 0 I'll be configuring 168.101.1. you understand? Fine. It will come up. And now if you want to advertise anything in BGP, there is only one way to advertise anything, right? With using network command. Now in CCNA we learned this definition of network command, that network command is used to advertise prefixes. That definition is correct only for BGP, not for any other routing protocol. If you are saying that network command is used to advertise prefixes into routing protocol, that is correct only for BGP, because in all other routing protocols uses of network command would be just to enable routing protocol instance onto interfaces, right? Finally, only that information will be advertised into routing protocol updates or in routing protocols which is configured onto your interface itself, right? But here in BGP, it doesn't matter that what you configured on interface. It matters only that what are you advertising with using network command. So in BGP, network command is used to advertise your prefixes into BGP, right? So this time I'm going to advertise like 192.168.101.0, right? So of course it will be advertised. Remember, if you are defining or if you are advertising classful network in BGP with using network command, you are not required to define your mask value, right? But if you are having classless networks, let's say for an example, if I said network 1111 do show IP BGP, does it have that entry in its BGP table? No, 111 is not there. So if you are advertising classless network into BGP, it is mandatory to specify its subnet mask. And one more thing, if you are advertising anything into BGP, first of all, it must appear in your local BGP table. If you advertise anything in your BGP on a device, on a router, and if you didn't get that prefix available in your local BGP table, it means that that prefix was not advertised successfully, right? So if you have advertised anything into BGP successfully, which means you must find or you must get that prefix available in your local BGP table. Fine. So IP BGP, still you do not have that 111 over here, right? So I will say network 1.1.1 and then I'll be saying mask value and 255 and 255, right? Do show IP BGP. Check it out now. There is a rule in BGP that whatever you are advertising in BGP with the help of network command, there is a rule in BGP that whatever you are advertising in BGP with the help of network command. Right? That prefix must available in its local array. That prefix must available in its routing table. If you are advertising that prefix which is not available in its local routing table, then it will never be propagated in its BGP table. It will never be populated in its BGP table. I hope you people understood. Good. Let's move on R2 now. We must be able to see them onto R2 as well in its BGP table. You see. Now it is not best on R2. Is it best? For best, this symbol will always be there in the beginning of the prefix. And if it is not best, then it is not going to install them in its local. Yes, now it is best. Check it out once again. Huh? Okay. Yes. They appeared, no?
Yes, sir. The paired ones. They are paired ones. Yes.
But how? Actually, in BGP, as I told you, the very first rule is next hop must be, but BGP does not rely on default. So if you configure here now like this, IP route, tell me. Understood? Clear? So in this way you will be doing it. Once again I'm going to remove it. No router BGP 200 from R1. No router BGP 100. And this time I'll be drawing this diagram in this manner, that here on R1 I'll be using AS100. On others I'll be using MOVE1 R1 router BGP. Fine. Oh, sorry. Neighbor 12.1.2 remote AS is going to be this time. On R2, router 200, neighbor is 12.1.1, remote AS is network, right? Yeah, we can advertise it. The network One more thing. Let me configure BGP on R3 as well. Router, BGP 200, neighbor, remote assist, neighbor, 34.1.4, remote assist this. Finally on R4, neighbor. Fine. R1 must give prefix to R2, R2 must advertise that towards IBC neighbor R3. Now let's move on R2, so IPBGP. Next hop is what? 12.1.1, and it must become best path very soon, right? You will see sooner that this prefix will become best, because this time next hop is directly connected, right? It is reachable. So on R2 it will become best. Yes, it has become best, and also it will advertise it towards R3 now. Towards R3, yes, so IPBGP, you can see that okay, this prefix is available now in its BGP table, right? And next hop is still R2 received it from R1 and with the next hop 12.1.1, and R2 has given it to its IBGP neighbor, and it didn't modify its next hop address. So it has also proved that whenever you will give an update to your IBGP neighbor, it will never modify its next hop address. Understood or not? Fine. So now it will never make it best, because its next hop address is not reachable at all from R3. R3 doesn't know anything about 12's network, right? So as I told you that if next hop address is not reachable, it will never define that path as a best path. Right? Fine. That is why on R4 you can't get anything. Even on R4, even if it is best on R3, then also you will not get anything on R4. Because if R3 is receiving anything from its IBGP neighbor, it will never forward it towards any other IBGP neighbor. Are you getting my point? So this time you have learned that you know how to advertise these prefixes in BGP. One more thing I will show you now in BGP, that show run pipe section router BGP. By default, auto summarization is disabled, and that is why it is mandatory to mention your mask value. That is why it is mandatory to define your mask value for classless, I mean during advertisement of classless networks. But if you say router BGP 100 auto summary, and then after you say network 1.0.0.0, you will see that it will be advertised now. Do show IP BGP, check it out, because now it is possible to advertise it, because after auto summarization this prefix will become like this 1.0.0.0. So remember that if your auto summarization is disabled, then it is mandatory to specify mask value along with your, I mean during the advertisement of classless networks. But if you have disabled auto summarization in BGP, then after you can advertise your classless networks onto their classful boundary. You can advertise classless networks onto their classful boundary. However, 1.0.0.0 is not available in its routing table exactly, right? But this time, because you have disabled you have enabled auto summarization, right? You have enabled auto summarization. That is why it is possible to advertise this prefix now. Is there any problem now? Fine. Once again, I'm going to say node or summary. You will see that this prefix will not appear anymore in its BGP table now. Now you are mandatory, I mean it is mandatory to specify mask value during advertisement of that classless network, right? So say network 1.1.1, say mask, do show IP BGP, check it out. Right? If you do not want to use network command in BGP, do show run pipe section router BGP. Say no network this, no network this, no network this. You can also advertise your prefixes. You see do show IP BGP. Does it have anything? You can say redistribute connected. So all the connected prefixes will get redistributed into BGP table now. Do show IP BGP, and their origin code will be This is another way to advertise prefixes in BGP. Along with this command redistribute connected you can use. So in connected prefixes also you can specify that I want to advertise only these prefixes in BGP. Let me show you now. All these three prefixes are having same attributes, right? I'll move on R2. So IPBGP, all these three prefixes are coming and it is giving, I mean R1 is giving updates to R2 after performing prependation, right? Now I'll say clear IPBGP star in. I'm not gonna say clear IPBGP star because if I say clear IPBGP star, it will tear down neighborship with all BGP peers, right? And will re-establish peering. But if I say clear IPBGP star in, which means I will send a route refresh message to my neighbors to refresh my, to retransmit all the updates, right? To retransmit all the updates, and this route refresh capability is by default enabled. In older versions, this route refresh capability was not by default enabled. That is why this command was not possible to configure in older versions of BGP. But now in this, we are having this capability in BGP by default, this route refresh capability. So you will see that it will generate a route refresh message. You see that it generated a route refresh message, this R2 towards R1, right? Even you can look at this, that okay, this is generated by 12.1.2 and towards 12.1.1, and this is route refresh message, right? Then after it you can see that it has generated one message, one update packet, and in this update packet you can open it. You can open this BGP, this is path attribute, right? And it is containing only one NLRI. It is having only one NLRI, but one NLRI can have multiple prefixes, and you can open them, you see, and none of them, under NLRI, your prefixes are not having any path attribute. For path attribute, we are having only one field over here, like it is containing origin code, AS path, next hop, multi-exit discriminator, right? But it does not have local preference. You know why? Because it is giving an update to its eBGP neighbor. So whenever updates will be populated towards the eBGP neighbor, it will never contain local preference in all those updates, right? So that is why there is no local preference available in its update packet. One more thing I would like to tell you. Now, under a single NLRI, if you are having 100 prefixes, there will be a common path attributes for all of them, right? That is why during updation between two BGP peers, it does not consume too much network bandwidth, unlike IGPs, because in OSPF and EICRP, they advertise everything along with each prefix. But in BGP, there is a concept of NLRI. One NLRI can have multiple prefixes in it, and for a single NLRI, there will be a common path attributes. So it will not require to attach all these path attributes to each prefix individually. I hope you people have understood it now, that why BGP required lower bandwidth than other routing protocols, right, during sending updates. Fine. So all these things will happen in BGP in this manner. Then after you can look at R2. R2 is having, like these prefixes in its BGP table in this way. What does it mean, this R? This is RIB failure. That means RIB failure, which means that these prefixes are best actually in BGP table, but they are not getting installed in its routing table. You know why? Because these prefixes are learned from eBGP neighbor. By default their AD value will be 20, but for 111 I configured this route statically, so by default its AD value will be 1, and 12's network is directly connected, and by default its AD value will be 0, and lower AD value will always preferred over higher AD value. So that is why it is not installing it. It is not installing this best path in its routing table, but still it is best, and because of it is best, so now it can forward these prefixes information towards its neighbor R3. Because in BGP there is a rule that it will always advertise best path information towards its neighbor. So now you can look at R3 and you must find all of them in its BGP table, but still it is not best just because of next hop address. Just because of next hop address from R3, 12's network is not reachable. 12.1.1, it does not know that how to reach 12.1.1.1, right? So how can we solve this problem? So there is a command actually that if you are receiving, see what is happening here now, R2 is receiving prefixes from its eBGP neighbor and giving them to its iBGP neighbor. If such situations are there in your network, then to solve this problem you can configure this command on edge router BGP 200 then neighbor 1223.1.3 next hop self. Configure this command, but remember this next hop self command can work only on edge router. Means that this next hop self command can work in that condition when you are receiving from eBGP neighbor and giving them to iBGP neighbor. In that case it can modify their next hop addresses automatically. So now whenever you will see all these prefixes available on R3, then its next hop address must be 23.1.2, and now all these prefixes are best, and that in this condition now R3 will also install all these prefixes in its routing table. But because it received all these prefixes from its iBGP neighbor, that is why by default their AD value will be 200, right? And now if you look at show IP BGP summary command, you can see that it received from this neighbor 3 prefixes, right? And that's what we are getting in its BGP table, right? And all of them have also installed in its routing table, and you can see that I hope that's fine. I mean, you understood all these points now, right? Fine. After all, now you know very well that for R3 all these prefixes are best prefixes, right? And R3 have installed them into its routing table as well, right? But R3 is not giving anything to its neighbor R4 because there is a rule. There is an iBGP rule. So this rule is called iBGP rule, which means that if you are receiving anything from one of the iBGP neighbor, then you will never advertise that information towards other iBGP peers, towards other iBGP neighbors. I hope all these things are fine now for you, right? Fine. So now if R2 is having neighborship with R4, then of course R2 can give all these prefixes to R4. But this time even R2 doesn't know that how to reach R4. So in this case now on all these 4 routers R2, R3, R4 and R5, it is mandatory for us to configure any IGP, interior gateway protocol, and then I will configure one loopback interface, and with using their loopback interfaces we can configure IBGP peering between all of them, right? One more thing, do not think that to form fully meshed IBGP peering, your physical connectivity must be in fully meshed way. Do not think like that. Even without having fully meshed physical connectivity, you can form fully meshed IBGP peering. Do not get confused in between fully meshed physical topology and fully meshed IBGP peering. Here we are not required to have fully meshed physical connectivity, because in background we can configure any IGP like RAP, IGRP or OSPF, right? And with the help of those protocols we can learn their loopback, each other's loopback prefixes, and then with the help of their loopback networks we can form IBGP peering between all of them. So if R2 will be having neighborship with R4, then definitely it will be giving prefixes to, it will be giving an update to R4 as well. And updates, all types of packets will always be forwarded as unicast messages, unicast packet. So whenever R2 will forward any unicast packet towards R4, so it will be forwarded by R3 in the direction of R4 without any problem, because R2 will become transit device in that case. Because in BGP, all the updates, all the packets will always be unicasted. So if you form neighborship, indirect neighborship in between R2 and R4, R2 will be giving an update directly to R4. So whenever that update, that packet will be delivered onto R3, R3 will perform routing lookup in its routing table to reach that destination. So R3 will send that packet out from fast Ethernet 0 by 0. Is not it? That's fine. I'm not gonna to break this rule right now, right? Before going to break this rule, I'll be doing some other things here, right? Like let me tell you that you can also form your, during BGP configuration, you could also use this one, this method. No router BGP 100 by default, a default address family IPv4 is always created. That is why neighborship came up in between two devices automatically without activating neighbors. In BGP version 4, it was not available in BGP version 3. In older versions of BGP, this default address family concept was not available. But now in BGP version 4, we are having a default address family that is IPv4 unicast, which is by default enabled. To disable that, I'll say no BGP default IPv4. I've disabled this default address family now, right? Similarly, I'll be moving on R2 and I'll be saying router BGP 200 neighbor, sorry, not neighbor. I'll be saying no BGP default IPv4 unicast. So this time I have disabled this capability of BGP, right? By default, this capability was enabled. So this time you will see that if I say neighbor 12.1.2 remote AS is 200, and similarly if I move on R2 and if I say neighbor 12.1.1 and remote AS is 100, you will see that neighborship will never come up. Never ever. Show IP BGP summary. Even if they have not initialized it. Right? So neighborship came up previously in between two BGP speaking routers automatically just because of this default address family. And this default address in this default address family, neighbors are by default activated. So now you will require to create your address family by yourself, right? You will be required. Like I already said, neighbor remote is this, right? But still peering didn't came up, right? So this time I'll be saying address family IPv4 unicast manually, right? And then I have to say activate. Similarly, I have to move at the end of R2, say address family IPv4 unicast, say neighbor 12.1.1 and then say activate. You will see now that neighborship between these two routers will come up now. So if they ask you to disable default address family in exam, you will be disabling address family in this manner, and if they ask you to form neighborship, then you will be forming neighborship in this manner. In router mode, you will be defining remote AS, update source or whatever it is, but rest of the commands will be configured with inside address family. You will be required to create your address family manually if they have asked you to disable default address family. Right? So if you disabled your default address family IPv4, your BGP neighborship between two routers will never come up. You will require to create address family manually, and it is something like that you learned in EIGRP as well, right? Hopefully you have also understood this point of BGP, right? Fine. So now say router BGP 100, say redistribute, connect it once again, right? So that now, okay, R2 does not have any neighborship, so I'll be saying that neighbor 23.1.3 remote AS is what? 200, right? Address family IPv4 unicast neighbor 23.1.3. Fine. Right? So now you will see that R3 will again form neighborship with R2. Neighborship should come up now. right? So IP BGP summary. It has received all the prefixes. Next hop is not modified, so again I have to say next hop self, right? So on R2 you have to say router BGP 100. You can't say now, sorry, router BGP 200, right? On a single router you can run maximum 1 AS of BGP, right? So now say neighbor 23.1.3 next hop self, but this command is not configured over here, right? Now you have to move under address family, right? So say address family IPv4 unicast say neighbor 23.1.3 and then say next hop self. So in this way you will be doing this configuration. After doing this configuration, again you can move on R3 and you will be saying 23.1.3 and all of them are best now. You understand? Fine. Okay. This time what will I do here? I'll be using AS200 and on R3 again I'll be using AS100. So that we will see that now R1 and R3 they will not be able to exchange prefixes, right? And now on R2 I'll remove it, router BGP 200 no neighbor move on R3 once again configure 123.1.2 remote ASs on R2 neighbor address family IPv4 unicast neighbor sorry you have to say activate, right? So we will see that. So IP BGP summary, check it out. It received 3 prefixes from its neighbor 12.1.1. It has to forward those prefixes towards R3 now. So IP BGP, you see summary neighborship has came up, but it have not received anything, right? Now say debug IP BGP update. Say clear IPBGP star in means that you are forcing your neighbor to retransmit all the updates, right? So it will send route refresh message to its neighbor, that then further neighbor will send updates towards it. Just wait for a moment. See, denied due to on AS. Denied due to AS path contains on AS. So this rule is by default enabled. Tell me. And if you want to allow them, you're going to break this rule. Allow AS in. Router BGP 100 neighbor 23.1.2 allow. See, so IP BGP, right? All of them are present now in the BGP table of R3, right? So we can also allow them. We can break this rule by using allow AS in command. Any problem in it? I mean till now in BGP. Is everything fine? Good. Then after it If you wanna change, timers in BGP, that is very simple, right? Like router BGP timers BGP. First of all, it will ask for keep alive interval, and then like you wanna make it 30, then hold down interval. You can change in this manner, or you can say right. And the advertisement interval for IBGP neighbor it is 0, for EBGP neighbor it is by default 30 seconds. You can change it from here, right? So in this way you can modify your timers in BGP. Similarly, if you want to configure authentication in BGP, that is very simple. I'm on R1 router BGP 100 address family IPv4 this time because I'm using address family, right? So I have to say neighbor 12.1.2 and password is what? Neighborship will go down but after 3 minutes, so you have to wait for 3 minutes. Then after notification has been received, it has broken neighborship due to authentication failure, right? Here you can see that peering is going down due to, forget about it. Let's move back again on R2 and router BGP 100 say 200 address family IPv4 unicast neighbor 12.1.1 say password is Cisco at 123. Neighborship must come up now. You will see that neighborship will come up between R1 and R2. Yes, but you will see that even after establishing neighborship between R1 and R2, it will keep on to give you these messages. You know why? Because still it is having that older TCP connection. It is still in FinWait state, right? So till it is having this TCP connection in its TCP connection table, it will be giving you these MD5 digest and bad authentication and bad authentication, right? Now you have two things: either wait for clearing this connection from its TCP connection table, or you can clear it manually. To clear it, now it won't show you anything. Any problem till now? Tell me. Fine. Let's look at the default configuration of BGP. What is this? No synchronization. By default, synchronization rule is disabled in BGP. First of all, you have to know that what is synchronization rule. So remember, this synchronization rules applies only for IBGP peers. Very first thing, that the synchronization rule applies only for IBGP peers. That is why technically it is called IBGP synchronization. Technically we will call it as IBGP synchronization. And this rule nowadays, this rule is by default disabled nowadays, right? Previously it was by default enabled in older version of BGPs, because previously we were not having MPLS on, something like that, but nowadays we are having MPLS tag switching, so we don't require it at all. Why it was necessary to have, right, to have synchronization enabled in BGP? Why was it required? See, yes, it was required to prevent BGP from black holing condition. Synchronization rule was required to enable in BGP to prevent BGP topology from black holes, because unknowingly it was possible to create a black hole in BGP, but unknowingly, right? So to eliminate that fault that created by you unknowingly, this synchronization rule was there. So by default it was enabled. What does it mean actually? See, if you enable synchronization rule on any router, after enabling synchronization rule, if you receive anything now from your IBGP neighbor, if you receive any prefix from your IBGP neighbor, then same prefix must be received with the help of IGP as well. IGP means either RAP EIGRP or OSPF or ISIS. After enabling synchronization rule in BGP, then after, if your router receive anything from its IBGP neighbor, the same information must be received with the help of IGP. Then only it will make it best. Otherwise, it will never make it best. Even we can prove it. I'm on R1. I'll say no router BGP 100. I'll move on R2. I'll say no router BGP 200. Similarly, I'll be saying like router BGP 100 neighbor 12.1.2 remote AS is 100, right? Then I'll move on to router BGP 100 neighbor 12.1.1 remote AS is 100. You understand? And then I'll be saying synchronization. And after enabling synchronization, it is mandatory to clear your BGP process once. So clear it and then say router BGP 100 say redistribute connected. So all the redistributed prefixes, right, must get redistributed into its BGP table. All the connected prefixes, right, must be available in its BGP table. But wait for a moment. Will take some time to insert all these prefixes in its BGP table. अभी तक बीजीपी में बी भी नहीं पढ़ा है तुमने। ये सिर्फ मैं इसके जो छोटे छोटे पॉइंट्स हैं, बहुत स्मॉल पॉइंट्स हैं ये, राइट। आई एम जस्ट ट्राइंग टू कवर ऑल दी स्मॉल टॉपिक्स और स्मॉल पॉइंट्स ऑफ बीजीपी, बिकॉज प्रॉब्लम यहीं पे आती है, इन्हीं छोटे छोटे पॉइंट्स में प्रॉब्लम आती है, कभी बड़ी प्रॉब्लम नहीं होती है। So IP BGP, all of them are here. We must get them onto R2. You see 101 is not best. You know why? However, its next hop is reachable, but still it is not best. And first two prefixes are best because first two prefixes are available in its routing table with using different sources. Even if I remove this static route, let me remove this static route from here now. It's been so long time. I configured it, right? Let me remove it. Now check it out. Show IP BGP. Only 12's network is best now, just because it is directly connected now, right? So now you see that 111 for 111, its next hop address is reachable. For 191.168.101.1, 101.0/24 for it, its next hop address is reachable, but still BGP has not defined them as a best path. BGP hasn't defined them as a best path. So what to do now? It is just because of synchronization. If I disable this synchronization, you will see that BGP will immediately make them as a, or will define them as a best path. immediately. But this time synchronization rule is there. So what synchronization rule says? It says that if you are receiving anything from IBGP neighbor, then same prefixes must be received from any other source as well, like static route, IGP, like EIGRP or OSP or whatever it is, right? So this time I'm going to configure EIGRP as well. So router EIGRP 100 node assembly network 000. Similarly, I'll be saying on R2 router EIGRP 100 node assembly network. Show IP EIGRP neighbor, show IP route. All the routes must available in its routing table via EIGRP. Now all of them are best. Now you will ask me that if we are running IGPs, then why do we require to configure this BGP? What's the need over there, right? See, let me explain you in this manner. Let's say this is customer edge router, right? This is provider edge router. This is connected with P router. This is connected with another P router. This is P router. This is P provider router. This is provider router, right? And this is PE router. This is also PE router. This with this PE, same customer is connected, customer B side, right? This is customer A side. This is B sides, and they are same customer, right? Now what you did in between, here you are running OSPF internally. This is service provider network. So you are running here OSPF internally. Now what you did in between this, on this P you created one loopback, on this P you created one loopback, and with the help of now OSPF, these loopbacks are reachable to each other, right? So what I did, I configured indirect IBGP peering. So now customer A will be giving its prefix to PE1, PE1 will be giving them to PE2, and PE2 will further give them to customer B. But whenever they will try to ping with each other, right, their traffic will be dropped by these core devices, because on core devices only OSPF is running and you didn't redistribute it BGP back into OSPF. So there is a black hole now, and this is called transit AS now. This AS will be known as transit AS. This is service provider. You're having so many routers over there. You are having one customer. Customer is having two sites, site 1, site A, site B. Site A is connected with PE1, site 2 is connected with site B is connected with PE2. Now internally provider is running OSPF. What provider decided that let's configure indirect neighborship in between PE1 and PE2. Indirect neighborship because they are reachable, and in BGP you can do that. Fine. So PE1 is having neighborship with PE2. So whenever with BGP PE1 will receive any prefix coming from customer, it will be giving those update to PE2 directly. And on other routers, like on other P routers, you are not running BGP, right? So those routes will be available on PE2, and then PE2 will be giving them to customer B. Same, if PE2 is receiving anything coming from customer B, PE2 will be giving them to PE1, and further PE1 will be giving those prefixes to customer A. Customer A is having prefixes of site B. Site B is having prefixes coming from site A, but still they cannot ping with each other, because ultimately their packets, their traffic has to travel through core routers, P routers, and these P routers do not have their prefixes information in their routing table. So that is called black hole. To prevent transit AS from these black holes, we were having this synchronization rule over there. Now enable synchronization rule here. If you enable synchronization rule on PE1 and PE2, you will see that whatever PE2 will receive from PE1 will not make them as best until unless it receives those prefixes with the help of OSPF. And if you perform redistribution on PE1 from BGP into OSPF, which means that PE2 will start receiving those prefixes with the help of OSPF as well, which means that now all the routers will be having those prefixes in their routing table. Similarly, if P1 receive anything from P2, P1 will not make them best until unless it receives them with the help of OSPF. So again on P2 you will require to redistribute BGP back into OSPF. Now P1 will start to receive them with the help of BGP as well as with the help of OSPF. So that now P1 make them as best path in its BGP table. Once it will become best, it will start forwarding them towards site A. And now whenever you will try to ping from site A to site B, they can ping with each other very easily, because now all those prefixes are available in the routing table of P routers, core routers. So that is why at initial level it was mandatory to enable synchronization in case of IBGP. But nowadays we don't require it at all. You know why? Because we are having MPLS. In MPLS we don't require to have all the prefixes available on core routers. You just need to have prefixes available only on edge routers. Just because of MPLS, the synchronization rule has been disabled by default now in BGP version 4. So the synchronization rule is not synchronization rule. It is called actually IBGP synchronization rule. If you enable this rule, if you receive anything from IBGP neighbor, you will BGP will never make it best until unless it receives same prefixes with the help of IGP, any other source. Done. In T-shoot they can do it knowingly. They can enable synchronization. Whatever they will now, whenever any you will enable this IBGP synchronization rule on a router. If it receiving anything from its IBGP neighbor, it is not going to make it best. So you have to be very careful. So if you think that okay, everything is fine and still these prefixes are not best, which means might be possible that IBGP synchronization rule is enabled. So you have to say no synchronization, and then after it is mandatory to hard reset your neighborship. Like if I remove now once again EIGRP between R1 and R2, say no router EIGRP 100 now you look at R2, so IP BGP, check it out. Is it best now? This is the way, right? कल आओगे? नौ से 11 आ जाओ फिर, अगर आना है तो. If you can come tomorrow,